Well, we haven't had very good weather recently, have we? I think perhaps it's a little bit naughty to impersonate people, but we have a chap in the West of London Astronomical Society who presents the observations every month, and every month he says, oh, we've had a terrible month, it's been cloudy all the time, and it's always like that. And every year at the AGM he gives a review of the year's observations, and it's been a terrible year. But it really has been terrible, hasn't it? Despite that, surprisingly enough, BAA members somehow have kept the observations coming in, whether it is by observing between clouds in brief cloud gaps, or hiring telescopes in remote parts of the world, or even moving to different countries to observe. So really one must pay tribute to their perseverance in carrying on the tradition and keeping the flow of observations coming for our meetings and our papers. But sometimes there is a bit of disappointment. Here's a little bit of a Facebook correspondence with some well-known members of the BAA. Somebody is trying to spot that comet for the last couple of nights, and Dominic Ford says, from what I've been reading, everybody's been squinting at Ursa Major and failing to find 41p. Andrew Wilson replying, glad to hear it's not just me. And then the director of the Deep Sky section, Callum Potter, says, oh, I thought I had a hint of it in 10 by 50 binoculars, but nothing. So I'll come back to 41p later, but it actually is quite difficult to see, despite being quite bright comet on paper. So here's the sun, which, as we've heard, has been quiet recently, but it's not completely featureless. It has I wouldn't say it's completely dead at the moment. Here's an image from Mick Nichols in Sheffield, and he had to take this through thin layers of cloud, as you usually do in Sheffield, and he accumulated a series of images which he put together as a mosaic, and he said he had terrible difficulty getting the brightnesses all to match, to get rid of the gradients of brightnesses across the image to produce a homogeneous hydrogen alpha image of the sun. And this is just a few days ago, 26th of March. So it's a lovely image of this lovely egg-shaped object in the sky. Ron Johnson has been carrying on imaging in white light, and here you see March 27th, only a couple of days ago, AR 2644, and then on two successive days you can see how that small spot group has changed. So there are things to see in white light and hydrogen alpha light on the sun, but the sun also influences us in other ways. We had an aurora alert from the director of the Aurora section put out, and she says that a coronal hole occurred on 27th of March, and I thought this sounded rather exciting. The field is unstable, both positive and negative. It sounds like something Scotty might have said on the Starship Enterprise. The field is unstable, both positive and negative. I cannot hold a captain. However, and the wind, it created it's a solar storm, and she was predicting that it would cause an aurora in northern Scotland, and indeed it did come down the line just less than 24 hours later, which is only the night before last. And here's the aurora from the north of Scotland, imaged by Dennis Basinski, and lovely star fields there. You can see Lyra just rising in the lower right hand corner there. And slightly further south in Elgin, Alan Tufts took that picture. And on this one, which is a bit of a wider field, you can see these vertical rays rather nicely. But none of this is anything compared to what they saw from Iceland. And here's an image from Iceland by Andy Green, who leads tours to see the aurora there. So, also very close to the Earth, practically almost within the Earth's atmosphere in fact, came this near-Earth object. And this is a really great story. One of our most dedicated observers, Peter Birtwistle, who's one of those people who concentrates on one thing and does it really well, does it in a world-leading manner. He observes near-Earth objects, he discovers them, and he recovers them. This object was discovered by a professional survey, the Mount Lemmon survey, and it was estimated to be only 3 meters across. And Peter was the only person amateur or professional who managed to recover this object. It sped across the sky so quickly at the time that he imaged it here, his field of view is about a third of an arc minute, and it was doing about that in 1 minute. So he had extreme luck in capturing it, but he also took his opportunity. He actually had to make his own calculations from the information that was supplied by Mount Lemmon to try and narrow it down where it might be, and he only managed to narrow it down to a 5-degree area of the sky, most probably, and he managed to pick it up, and it was just at the distance comparable to a geostationary satellite when it passed by the Earth on March the 21st, and it was only visible for a few hours, and he was the only person who recovered this, the only person whose images allowed the orbit to be calculated accurately, and the whole story of that is on the BAA website, and it's worth reading the whole account of it to see how much trouble he had to go to and how lucky he was. So it's an example of luck favouring the prepared and the dedicated observer. Mercury is coming into view in the next few days. This is a chart for April the 1st. It has its greatest elongation, April the 1st. It'll be 19 degrees away from the sun. So at the beginning of civil twilight, the end of civil twilight, when the sun is 5 degrees below the horizon, Mercury is about 12 degrees high. So actually we've got this new thing in the BAA called Observer's Challenge. We've got an Observer's Challenge on the comets. It just occurred to me this would be quite a good idea to have an Observer's Challenge to see who can spot Mercury in the evening sky. So this will be the best evening opportunity of the year, only for a few days. Don't miss it. Mercury over the first few days of April, it will be at 39% phase, magnitude 0. I haven't got any recent images of Mercury, but here's images from a few years ago that I took, and with webcams we can actually capture some real detail on Mercury, and the bright spot that's shown on that disk on the right hand side of the disk, that's actually one of the main ray crater centers on Mercury, which is called Antoniadi, I think. Venus, of course, has now disappeared from our sky. It passed through inferior conjunction on March the 25th, and in this object, this may not seem like anything, but just in the center there's actually a tiny crescent of Venus, and that was just 24 hours before inferior conjunction, imaged by Geoffrey Johnstone. It's now going to become a morning object heading towards greatest western elongation in June. The past apparition of Venus has been very well observed. Here's some lovely drawings and different colour filters by Paul Abel in February. Then I managed to get an image of the night side of Venus. I imaged this on March the 2nd, and this is an observation in a very particular infrared filter, about 1,000 nanometers, which only passes the light longer than 1,000 nanometers, and you can actually pick up by this method the glow of the dark side of Venus, because the atmosphere has a window of transparency around that wavelength, and the dark side of Venus, as it is cooling down, continues to glow, and we can now capture that with the current generation of cameras, of amateur cameras, are sensitive enough in the infrared to capture that. So what's happened here is that this is a very overexposed crescent of Venus, and this is the dark side just showing through, and in the lower plot I've attempted to make a projection of that image and compared it with a topographic radar image of Venus, and what we should expect to see is that the slight contrast variations should correspond to different heights of the topography of Venus. The higher mountains should be cooling down faster than the valleys. I'm not convinced I've really proved anything there, but this is an observation that can only be performed for a few days when the crescent of Venus is sufficiently thin, and yet Venus is in a dark sky. It has to be in a dark sky, otherwise you flood out the exposure. So Venus continued to get smaller and smaller. here's an image from taken by Bill Leatherbarrow on 15th of March, and the same day as Martin Lewis compared the sizes, the angular sizes of Mars and Venus. And of course, he's moved them about a bit. You wouldn't actually get Mars on top of Venus like that, because you wouldn't be able to see Mars through Venus, obviously. So it carried on getting smaller. This is a video which may or may not work by Nick James. It was a video that shows gradually, he's taken it over a number of days, and it shows the gradual decline of the phase and also the change of orientation as it becomes more like a smiley mouth face as the face gets smaller. And it also has some nice bird song accompaniment. So it's a pity we can't hear it, because I did have a joke prepared about these. These are the actual Essex birds. You may have thought the Essex birds are, and the actual day of inferior conjunction, Chris Dole actually managed to take this image of Venus. It wasn't a very close inferior conjunction. Venus was about 12 or 14 degrees away from the sun. It was significantly away, so there was a bit of a crescent there, and it was actually Chris did very well to actually get that image on the day of inferior conjunction. The moon is going to be a thin crescent in the next few days, and then by April the 3rd, it's the first quarter. We've got the Stargazing Live events, hopefully over this weekend, where local societies will be organising events coinciding with the BBC programme. So in these days, it'll be a crescent and heading towards full on April the 11th and so on. We don't get much of a look in for lunar images in the sky note, so here's a recent nice example from James Dawson. Famous view of Plato there and the Alpine Valley, this amazing gash through the Alpine mountains. Looking backwards, since we haven't had a meeting since early February, I'll mention the penumbral lunar eclipse that occurred on February the 10th, and this was clouded out in England generally, but in Scotland they caught it. Alan Tuff managed to image it in Elgin, and people did say yes, it did look significantly to the eye, it did look significantly darker, because the whole of the moon actually went into the penumbra on this occasion. Penumbral eclipses are not spectacular, but people did say it was noticeable on this occasion. In the next few days, this is a plot for this Friday, and the moon is actually just down there, and this is the Hyades, so it's passing very close to the Hyades and Pleiades. So if you have observing events this weekend, it'd be a good way to find the Hyades and Pleiades from the location of the moon in the early twilight sky. Occultations. We've got an occultation of Aldebaran in April. It's a very thin moon, a 2-day-old moon, and it's a daylight observation. So that's in the handbook, but that might be worth chasing up. And since we haven't got another meeting before May the 17th, I'll mention that there's a grazing occultation of a star which is visible in a band across the south of Scotland and Northern Ireland, and that's a low thing. It's 12 degrees altitude, so that might be a challenging opportunity, but I'm mentioning that. Moving on to Mars, well, it's still just about visible. In civil twilight, it is, that shouldn't say 4 degrees high, that should say 14 degrees high. When just after sunset, it's about 14 degrees high. It's due west, it's heading towards conjunction in July, but up until very recently, we had images of it, and here's one from Martin Lewis in St Albans, where he's actually caught the Solis Lacus on the upper left there, and various other features. South polar cap, very tiny South polar cap, the top of that image, on a 4.4 seconds of arc disk, and one from the 24th, even smaller disk, Sinus Sebaeus, which is this dark area here, and Hellas, this brighter area, and Mare Acidalium is also visible there, and some clouds at the bottom there. That's not a polar cap, that's clouds there. So that's quite amazing that as recently as that we've had usable images of Mars. But of course people's attention are turning to Jupiter. Very well placed now, transiting in at 1:30 BST in Virgo. It's 32 degrees high. and it's heading towards opposition on April the 7th. And here's an image from Steve Knight, and there's Jupiter, and there's Spica below it, and he's also caught some geostationary Earth satellites in that image. Clyde Foster, a friend of some of us who's imaging from South Africa and who's visited us here at Burlington House on a couple of occasions. He's been producing some fantastic images because Jupiter is well in the southern hemisphere of the sky now. We're getting the best images from the southern hemisphere, and here's one of Clyde's images showing the typical appearance of Jupiter at the moment, and we've got this orange belt in this orange component's the North Temperate Belt, and that's a new feature of this apparition. Damien Peach has been using a remote telescope, and I think this is very much the way this kind of study is going to go. The remote telescopes are now good enough in terms of the pointing is good enough, and the CCDs are big enough that you can reliably point a remote telescope at a planet, a remotely controlled telescope, and you can take an image of it. And this is a 1 meter telescope in the Andes, and Damien seems to have got a special deal on this, or maybe somebody else is paying. I don't know who's paying for this, but he seems to be getting regularly images with this Chile scope, this 1 meter diameter scope, and so here's one of them. But this, I want to show you that this compares very well with Clyde's image, because this is exactly the same view. It's not the same night, but it's exactly the same longitude of Jupiter. Look how similar they are, and Clyde is using a C14, a 300 and whatever millimeter telescope. This telescope's 3 times the size, and it's really quite comparable.
David, is it still using camera
video
based?
Yeah, it's this is an ASI 174mm camera.
Right.
So
he's got to get all that gigabytes of stuff back.
I haven't looked into exactly how it works. I suspect the processing must have to be done on the computer at the observatory. But I don't know how it's done, because you would have thought, yeah, you couldn't get the image down in real time down an internet connection. But I know other people have been using this telescope. It can be hard. I think it's quite expensive to hire. But I think this is a harbinger of things to come in planetary imaging. Deep sky imaging has already gone this way to a large extent, and planetary imaging is following it. Here's another of these images taken with that telescope, and there's the great red spot. Obviously, the little red spot, or oval BA, this interesting little complex of dark spots down there. But here's another image from Clyde Foster, and you can see in this red light image, or possibly infrared, this very clear circulation of detail in the great red spot. And here's another of Clyde's images showing these interesting cell-like structure in the south equatorial belt, and these very prominent chevrons, which are blue in coloured light in the equatorial zone, that are prominent at the moment. But it's not a lost cause from the UK. Here's an image by Simon Kidd with a C14 from the UK, and really pretty good. And here's another one from Dave Tyler in Buckinghamshire. So people are able to get reasonable images of Jupiter, even though it's only 32 degrees high from the UK. And we've not many people producing drawings these days. Here's some drawings from Paul Abel showing what you might expect to see with a large amateur telescope under good seeing conditions. But I will show you another of Damien's images, because this is rather good for Callisto. I've taken this image and blown up Callisto, and look at all the detail on Callisto. So that's what you can do if you've got a telescope a 1 meter telescope in the Andes. And Damien's processing skills. The Juno spacecraft is going around. I won't show you any images from that, but they're all over the place. But it has a perijove on March the 27th, which is when it approaches close to the planet, and the track has been marked up by John Rogers on this image. And on this occasion, the operators of the spacecraft asked the general public to suggest objects for targeting, and John made some suggestions. He thought they should target a grey streak, which he termed this grey ghost in the south temperate belt, which is here, which is cyclonic circulation. And also he thought that maybe it'd be a good idea to have a good close look at the new orange component of the North Temperate Belt. And the images from that part of Jupiter may have been released today, so look out for those. I haven't seen them so far. Here's another piece of work by John Rogers, which is on the Jupiter section website, where he's been looking at these tiny white ovals and been comparing them, and they're getting closer and closer together, and eventually they've merged. And so he's been able to compare images from all over, generally southern hemisphere, but some from Japan, some from Greece, some from Italy, to provide this record of what's happening on these really unprecedentedly fine scales. Moving on rapidly to Saturn, it's not MAG plus 4, it's MAG plus 1.4. It's transiting at 6 BST. It's now really at the bottom of the ecliptic. It's in Sagittarius, so it's only attaining 16 degrees, so unfortunately it's not going to be well seen. It comes to opposition on June the 15th. And here's another image from Clyde Foster in red light, and this interesting, very, very small North Polar central spot in the middle of the hexagon. Here's a colour version, and you can see nicely the disk showing through the southern part of the disk, which is bluish because it's cold, just showing through the Cassini division. And I presume this is, again, the Chile scope in this Damien Peach image, or they didn't attribute it here. And there's the hexagon very beautifully. This image is the other way up, as you can see. And there's a lot of detail here. The spots, the spots in these latitudes. I can see 1, 2, 3, 4 little spots, another white spot there. There's sort of crenellations on some of it. If you look carefully, you can see an awful lot of detail there. Some meteor showers. I'm running out of time, so I won't go on about these, but the best one is the Aquarids in May, which is quite a high ZHR, but it's rather a southerly shower. And we also got the April Lyrids, which are favoured this year by not having any moon. There's several comets brighter than magnitude 11 from the UK, and the main ones to point out are 41P, Tuttle, Zhirbekhany, Krejnak, and they've got good names, some of these comets. And then there's at the bottom of the list, there's also still 45P, Honda Murkovas Pajuskova, hanging in there, which was very well seen a month or two ago. But the main ones at the moment are 41P, which is MAG 7, last estimates. It's very high in the sky, Ursa Major to Draco. It's visible in the evening. It's coming to perihelion on April the 12th. And the other comet that features in our current Observers Challenge on the website, that's Comet Johnson, which is in Hercules, and that's brightening, and that'll be good in late April. And here's a lovely wide field image of 41P by Steve Knight when it was in the bowl of the plough there. And homing in a little bit more closely, Martin Moberly got an image with a remote telescope, and that shows M108, which I think is also known as the Whale Galaxy. And here's a colour image from Nick Hewitt of 41P. If you want to know where it's, and it's another very indefatigable observer of comets is Tony Angel, who's been imaging them almost exclusively from his retreat in the Spanish mountains, and there he's got his analysis of 41P and trying to measure the flux of the comet there. And here's another bit of an analysis by Nick James, where he's performed a deconvolution on the image and shown up the asymmetry in the, it's not really a tail, but perhaps a bit of asymmetry in the pattern of the coma, which maybe is indicative of some sort of asymmetrical flaring from the nucleus. Its path is from the Ursa Major area now into Draco. Early part of April, it's in the tail of Draco, then passing the head of Draco mid-April and heading towards Hercules and towards Lyra at the end of April. So that's I've managed to image it from London, but not to see it visually. The other comet that's about at the moment, Comet Johnson, is really looks more like a comet. It has a definite tail, and that's in Western Hercules currently. Here's a colour image from Nick, and a black and white image from Dennis in north of Scotland. And variable star scene, well, I've got some information from Roger Pickard. He told me that RCRB threatens to return to normal brightness. I thought that was a bit of a curious phraseology. I don't feel threatened by a variable star millions, hundreds of light years away. I mean, we might be threatened by a nearby supernova, but not really by this one. Anyway, this is a very commonly observed, there's more observations of this in the BAA variable star database than any other star, and so it seems to have leveled out recently. And here's a spectrum of it from David Boyd, and I'll tell you a little bit about this. I looked it up, what we know about our corona borealis. It has the spectrum of a yellow supergiant. It's a peculiar star, and it's got a few hydrogen lines, but it's got carbon lines, as we can see in David's spectrum, and it's got molecular lines, and it's thought to be 90% helium, 9% carbon, 1% hydrogen, most peculiar star. It's a carbon-enhanced extreme helium star, and the theories about it, lots of theories, but the favourite theory is that it was formed by the collision of two white dwarfs, a carbon-oxygen white dwarf and a helium-rich white dwarf. And it's thought that the variability of it, which is pretty unpredictable, is thought to be due to a build-up of carbon in the atmosphere, which is periodically dispersed by radiation pressure, and then it starts building up again. Another variable star which has been attracting some attention is this one, which was quite obscure up until recently. It's called OV Boötis, but it had an outburst. It was noticed by a Japanese observer, and its last outburst was in 1984, so these outbursts are not common, and several observers in the section, Gary Poyner and Roger Pickard and a couple of others have been following it regularly ever since this outburst, and you see these patches of observations. These are because it also has a variability on a very short time scale as well, due to being an eclipsing binary. Every 66 minutes it eclipses, and that has a range of 0.7 magnitudes, and this is a more resolved time series showing the eclipses. So in about half an hour it falls by 0.7 magnitudes, so it's a thing you can just look at and see it changing in front of your eyes. So that would be quite a thing to watch. I've just put in one deep sky image of the many that are many excellent images that are submitted to the BAA galleries now and the members pages by our members. Here's a pair of interacting galaxies, NGC 4485 and 4490, imaged by Paul Downing, another of these lucky people who've relocated to Spain and have got permanent observatories there, and he's regularly contributing these marvellous galaxy images. And of course, spring is the time for observing galaxies in the Coma cluster and the Virgo cluster on spring nights. So public events, as I mentioned, Stargazing Live is on TV at the moment, and we've got a special group of pages, a little mini website on the BAA site, specially targeted at the public and beginners, articles for beginners and so forth. For some reason they've gone to Australia to broadcast this Stargazing Live, which seems a bit of a strange idea to me, because I would have thought the idea of it originally was that you show people in Britain what they can see with their own eyes, but if you show them what they're viewing from Australia, then I think they'll just put on another cup of tea and say, well, we can't see that from here. Anyway, but some of us are still trying to get the public out observing, and we've got, if you're in the London area, we've got some Stargazing Live events in West London, down at the Lido in Ruislip, and if weather permits, over the weekend, I and other members of the West of London Astronomical Society will be showing Jupiter and the Moon and so forth to the general public, and they'll are other events all over the country that societies have organised to support the BBC Stargazing Live programmes. So we've run out of time, and with a picture of the hub, which was is the location of the Baker Street Irregular Astronomers meetings in Regent's Park. They met last night, and that was clouded out as well. I'll wish you all a good spring observing. See you all at the next meeting in a couple of months' time. I hope we have good conditions, and good luck to all of you. Thank you.